Okay, we have here today a quick integral from the MIT Integration Bee 2022 regular season 19. We have the integral of x squared sine ln x dx. Okay, I know at least two different ways to do this. You could definitely go straight to integration by parts. I think what we want to do, we need something, this is the complicated part here, so we could differentiate this. I think what I'll do first though is do a u substitution. It just kind of cleans it up a little bit. So either way, basically the same thing, but we'll do this u substitution for ln x first. Take a derivative, du is going to be 1 over x dx. But actually, let's not do it that way. Let's solve for x first, I think, just to get a value for our dx. So x on this, rearranging this with log properties, we're going to have x equals e to the u. Now take a derivative, dx is going to be e to the u du. So when we do this, our x squared value is just going to be this squared. X squared we can write as e to the 2u. Go ahead and substitute. What's going to happen? X squared is going to be this thing, e to the 2u. Then we're going to have sine of u, and dx is going to be e to the u du. But now we've got the same base here and here, so let's just multiply those together. Adding the exponents, this is going to become e to the 3u. And now for this, let's just do integration by parts. We'll use the di method on it. For this, you could choose it either way. I think I'll differentiate e to the 3u and integrate sine u. Both these things are going to repeat, so it doesn't really matter. Differentiating first on the left, this is going to become e 3u, 3 pops out. Do it again, and we're going to have plus another 3 pops out, and this is going to become 9, e 3u. Integral of sine is just going to be minus cosine u. Integral minus cosine u minus sine u. The reason I stop here is we can see that this is a lot like our original integral, so it's going to be one of these repeat cases where we're just going to solve for this integral. So what I'll do is put a label on this one. We'll call this thing I. And so for this I value, we've got part of the solution on the diagonals with e to the 3u in common. So I'll factor that out. And actually there's a minus sign on both, sort of. No, we'll just do the positive e to the 3u. So we'll do e 3u. I think I will go out of order though, because here minus times minus is plus, so I can write this part as 3 sine u, and then minus this other part, which is just cosine u. This last row is going to be an integral, but what's going to happen, if we rearrange this a little bit, I can write this as minus 9, and then it's going to be the integral e 3u sine u. This thing's the same thing as our I value, so I'm going to just write this in as minus 9 times I. But then to solve this, let's just add 9i on both sides, add 9i over here. This stuff's going to cancel. On the left side, we're going to end up here with 10i equal to all this stuff. But then in order to isolate our solution, let's just divide off 10 on both sides, divide by 10 here. And then all we're left to do is let's just back substitute in order to finish it off. One thing we can keep in mind though, for this e to the 3u, it's just if e to the u equals x, then x cubed is going to be the same thing as e 3u. So putting this together for my final solution, we're going to have x cubed 3 sine ln x minus cosine ln x all over 10, add a plus c, and that's it. Okay, there you go. Good one today from MIT 2022. Thanks everyone for watching. Have a good day.